Hi everyone, in this video I'm just going to give you a quick reminder about solving linear inequalities. So just to give you the, foundational stuff here, we have the properties of inequality, and mostly they're identical to the properties of equality, of solving equations. You're allowed to add or subtract something from both sides. You have to do both sides to keep it balanced. This will not change the solution set. You could also multiply or divide both sides by any positive number without changing the solutions. But if you multiply or divide both sides by a negative number, this will change the direction of the inequality. It basically flips both numbers on a number line across zero and reverses their order. So this is the key piece, this change the direction business. If you don't do that, you're going to get in trouble. Other than that, I think everything's fairly easy. So let's just work through a few of these so that you can see. First, 7 minus 3x is greater than negative 5. So I could start by subtracting 7 from both sides of the equation. You do not have to show me a step like that every time, but I wanted to write it down to make sure you all could see it. So I will get negative 3x equals negative 12. And then, equals, this is the whole point, is that it's greater than negative 12. We need to divide both sides by negative 3. Which works out really nicely. All I'm left with on the left-hand side is an x, and all I'm left with on the right-hand side is a positive 4. But it's very, very important that we pay attention. This is no longer going to be a greater than, this is going to be a less than. And it's very easy to double check yourself and make sure you got it the right direction. What we've got here is a statement saying that if your x value is less than 4, the original inequality will be true. So you could try plugging in something like 3. So if we do 7 minus 3 times 3, which is 9, is that in fact greater than negative 5? So I get negative 2 greater than negative 5, which is a true statement. So you can check yourself and make sure you didn't miss a flip along the way somewhere. The other piece of this, and it's not hard, but I find that sometimes people just forget to even do it or think about it. We should be able to sketch these solution sets. This is kind of the beginning of some of the thinking and graphing we'll do later on. So I want to center on x equals 4. It doesn't even have to be in the center, but that's what I'm doing. I want to show that x is any number that's smaller than but not equal to 4. So this requires some shading. You can use different colors, whatever you like. Just make sure it's really clear that the line goes this way. And then to show that we want to get every number right up to 4, 3.999, 3.99997, but not include 4, we just give an open circle. So that one is a little bit hard to see, but make sure there's open in the middle, not filled in circle for that one. Okay, let's look at a little bit messier version, nothing too crazy, but just so you have some examples to look back through. What I notice here is I have some mess to deal with. I like to clear fractions or roots or any weird stuff along with parentheses right away if I can. So let's go ahead and distribute through both sets of parentheses. 3b minus 2b minus 8. And then on the other side, 3 minus 8b minus 8. And I would point out that sometimes people will think that they need to switch the direction of the inequality, but you do not. We did not multiply both sides by some random negative number. We just kept everything where it was on its side and rearranged a little bit. So there was no multiplying both sides by a negative 2. We just distributed through parentheses. I'm going to do one more cleanup step. So on the left-hand side, 3b minus 2b is just 1b. So I have b minus 8. On the right-hand side, I can combine the 3 and the 8. 3 minus 8 is negative 5 minus 8b. And then from here, I get to decide which side to move things to. So you can avoid having to flip the direction of your inequality just by moving things to the opposite side. Notice that's the same effect, right? Flipping the direction or moving to the opposite side. Either way, it switches up where your b's are compared to the less than greater than. So I get a 9b, and I add 8 to both sides. And I get 9b less than 3, negative 5 plus 8. And I can divide both sides by 9. Make sure you always reduce your fractions. So that should give me 1/3. Note that I never multiply or divide both sides by the same negative number. So I don't have to flip the direction at all. This one, it didn't change. If you had decided to move all of your b's to the right-hand side instead, you would have to switch the direction of your inequality because you'd have a negative number in front of your b. Again, with the sketching, I guess I was a little boring. This one's still a strictly less than. We're just going to have a 1/3 in the middle instead of a 4. So we're going to have b less than 1/3. And if you really want to be good, you can label that axis. That's representing all possible b values, and I'm marking off the ones that make the statement true. Just like in the first part, it was all possible x values. Okay, so nothing too crazy there, just a little bit messier. Let's do one more, and I only want to do one more because it's a compound inequality. I have a sandwich here. I'm saying 2 times 7 minus 5b is greater than 4 and also less than or equal to 20. And you can solve these using the same rules. You just have to make sure that when you do it to quote-unquote both sides, it's actually all 3 parts of this equation. So I will start just like last time with a distribute. 14 minus 10b. Again, I haven't done anything to all parts of the equation. That was just a distribute, so I don't even have to think twice about direction. Next, let's go ahead and subtract the 14. Again, what's new here is that you have to subtract it from all 3 parts of this equation. So you can take it out of the middle. You're going to get negative 10 on the left, which is less than negative 10b, which is less than or equal to positive 6. And then last step, we'll divide everything by negative 10. That is division by a negative number. So we will have to switch directions here. So we are going to get a greater than and a greater than or equal to. Negative 10 over negative 10 is positive 1. And negative 6/10, we can reduce that a little bit. Let's go ahead and divide out a 2. So that's a 3 and that's a 5. Negative 3/5. So b is between negative 3/5 and 1. That includes the negative 3/5 but does not include the 1. So when we go to draw it, anytime you sandwich an inequality like this, it means between, and you never want to do that if you're not trying to say between. So we're saying between negative 3/5, that's going to be the smallest, and positive 1. The 1 gets a open circle because we don't want to include it. The negative 3/5 gets a closed circle. And again, these compound inequalities, these sandwiches, mean between. So we will just shade the little bit in between those. It's not that we're going to do a ton of solving inequalities later, but this kind of thinking is really helpful for some domain and range and other things that we'll tackle. So it's a good one just to practice and have fresh in your mind. All right, thanks for watching.